All right, hello, Reese. This is section 8.6. We just turned in 8.4 section, so we skipped 8.5. There are 3 papers that you should have. All of you guys check to make sure you have these. They are the 8.6 notes, so normal distribution is what it has on one side. Then the next paper that you should have is something called the empirical rule. This sheet is what you're going to use to do your homework assignment with. It is on your notes right here, this bell curve, but bigger. Okay, so that's why I gave that sheet to you, is because it just gives you a bigger version of this so you don't have to like squint so hard. Okay, and then on the back side of that empirical sheet has a men-women height bell curve. We'll talk about that for a second. And then you should have a homework assignment. And Reese, I gave you the wrong homework assignment. Okay, I gave you a different, it was skills practice and practice 8.6, but I want to give you this one instead. I call this one the cookie sheet because it has a cookie on the one side. Yeah, it has a cookie on the one side. So this is your homework sheet. One thing that I want you to fix on this homework sheet is on the side that is not the cookie side. Everybody look, on the side that is not the cookie side. Number 13 and 14, find it. Number 13 and 14 on the non-cookie side says 86 to 96. Change that 96 to be a 95 instead. On 13 and 14. 86 to 96, and then change the second one also on 14 to 86 to 95, right?
Does this make the problem 86?
It makes it easier. It's making it easier.
96 to 95?
86 to 95. The interval is going from 86 to, so it should say 86 to 95. Does that make sense? You're changing the 96 to be a 95. Yeah. Okay? So those 2 problems fix that typo. Good? Happy with that? So, cookie sheet is your homework assignment. Reese, I think I gave you this one. Skills practice, practice. So, I'm sending that one. I don't know. Josie is collecting your homework, and I think she's going to give it to maybe Reese or maybe Maddie. I don't know for sure. But she should have it. Okay, so there's that. All right, so let's go to your note sheet. We're going to start there. We're only going to do half of this section, and then we're going to save the other half for tomorrow. Okay, and 8.6 is normal distribution. So we talked yesterday about how you can have positively skewed, negatively skewed, or symmetric. We're just doing symmetric ones today. So like this is a histogram, but it's not completely symmetric, but we're going to, it's symmetric enough to say that we're going to go off of this symmetric. It kind of looks like a bell-shaped curve. That's what we have. And a bell-shaped curve here and a bell-shaped curve here. Those are all symmetric distributions, okay? They call those normal distributions. Circle the word normal and put symmetric because that's what that means. Anytime they say normal, they mean symmetric, okay? And here's how this works. I know I've talked about this already before, but here's how this works. I'm going to use the numbers that they have associated with this bell curve. And let's say that these are talking about like ACT scores, okay? The average ACT score, according to this bell curve, is what? 24. It's the number that's in the middle, right? According to this, the average, ACT's average is not 24. It's closer to it's closer to 20 or 21. We looked it up, and 2 years ago, Blue Hill's average ACT score was like a 20.26. So, whatever. But this is the average, and the tallest tower is on the average, meaning the most people are scoring about 24. You have a few people that are on this extreme list over here that scored a 30, and then you have a few people over here that are on the extreme that are scoring 18s and below, right? Some people are scoring 30s and above, some people are scoring 18s below, but these people are not as frequent. No, these are not as frequent as the people in the middle. These people are not as frequent as the people in the middle who are scoring average, right? The most people are going to score the average, then you're going to have a few people scoring on the left and the right side. Yeah? That's how that works. I'm not answering any questions. Moving on. Let's go down here. There's something called the empirical rule. So what I want you to do is take out that second sheet that says the empirical rule. It kind of looks like this. Has a little bit of a difference to it. The one on your notes says 2.35. We're going to round that to 2.4%. That's how your empirical rule does on that sheet. So you don't have to change anything on the big sheet. Just on your notes should say 2.4. And then you have another section that the empirical rule has that is 0.1%. Okay? So if you want to fix your notes, you can, but this is how it's written on the empirical rule. They just round differently, which is fine. Okay? So here's how this works. Okay? I'm going to say that we surveyed 100 students. Okay? Where N is 100. Write this down on your notes. N is 100. And the average ACT score that these students got, let's say, is a 21. Okay, we'll go with a 21. And the symbol that we use for average is something called X bar, because it has a bar over the X, X bar, with a standard deviation of, let's say, 3. Let's say our standard deviation is 3. Now, here's what this means. This means that we are deviating by amount of 3 on either side of the 21. And the larger that number is, the more spread out my data is. So if I would have a standard deviation of, let's say, 5 instead, don't cross that off, but if it was 5 instead, my numbers would be more spread out, right? Okay, so we're going to go back with the 3, and here's what we're going to do. We're going to fill this bell curve out with those numbers. 21 is going to live here in the middle, okay? Then I'm going to add 3 to that. If I add 3, I get 24 here, yeah? If I add 3 again, I get 27. If I add 3 again, I get 30. Okay? Then I'm going to subtract 3 because 3 is the standard deviation. Okay? Adding 3. Okay? Now, here's the deal. According to what? They will give you that. They have to give you the standard deviation and the average. Okay? So according to the empirical rule, some old dead guy crunched a bunch of numbers, looked at a bunch of data sets, and he said that approximately 34% of all people score between the average and 1 standard deviation above average, okay? In this case, it would be 21 to 24. So he says that 34% of people are going to score between a 21 and a 24. On the opposite end, 34% of people are also going to score between an 18 and a 21. How did I get 18? Minus 3, right? If I subtract again, that would be 15. What percent of people score between an 18 and a 15? 15 and 18. What percent of people will score between those two? 13.5%, okay? What percent of people will score between a 12 and a 15? 2.4%. And what percent of people will score below a 12? 0.1%. That's not even 1%, that's 0.1%. So not very many. What? I think so.
0.1%?
0.1% of people will score below a 12, okay? Again, I'm just making these numbers up.
It is possible to score less than a 12.
Right, I'm just making these numbers up. I don't know exactly what the standard deviation is, etc., right? Okay? All right, let's go up here. What?
What are the little, symbols
If you
and
put
stuff
your name,
below?
birthday.
Okay, the symbols below. We'll talk about that here in a second, Josie. Hold on just a second. Okay, now, if we're talking about 1 on either side, listen to this. If we're talking about 1 on either side, 34% and 34% ends up being a total of 68%. So if we're talking about in between 18 and 24, 68% of people would score in between those two, right? If we're talking about going from 15 to 27, what percent of people score between 15 and 27? 95%. What percent of people score between a 12 and a 30? 99.7%. Do you see that? This is how this works. Yes, I know that. Shh, we're not talking about that right now. So, example 1, part A is asking me for information, but it's giving me some stuff up above here that it has to give me. It has to give me that information. A normal distribution has a mean of 21. What symbol do we use for mean again? Kind of mu. Mu is the symbol that we use for population mean, but we call it X bar for now. Okay? X bar. And then standard deviation of 4. What symbol do we use to represent 4? S. S is 4. Okay. Let's label our bell curve. So, what goes where? 21 goes in the middle. Okay, and then what's the next number up from 21?
25.
25. Next number up from that is 29. Next number up from that? 33. 33. Okay. Down from 21. 17. Then 13. Then 9. Okay. So it doesn't tell me what these numbers represent, but we can kind of relate that back to the ACT, I guess, again, right? 21 maybe is the average, and then 4 is the standard deviation. Okay. I used a standard deviation of 3 up above here, right? Not 4, 3. So what does that tell you about this data in comparison to this data?
Top one's more spread out.
Which one's more spread out?
Bottom.
The bottom one's more spread out, right? The standard deviation is larger. So my range of values is wider, right? Here we're going from 9 to 33 rather than from 12 to 30, right? That is more spread out. All right. So we're just going to look at, it says find the range of values that represents the middle 68%. Middle 68%. Okay, so if you go to your empirical sheet, which looks like this, the middle 68%. You see where it says 68% within one standard deviation, right? That is from this mark on this side to this mark on this side. 68% of people will score between those two. So according to this, if average is 21, what percent of people, or 68% of people will score between what and what?
21 and 29 is 68.
68% will be between 17 and 25. Yes?
Well, if we want to find the percentage between 21 and 29, can we just like...
Just wait. We'll get to that. We'll get to that. We'll get to that. Hold on. So 17 and 25 is the middle 68%. So 68% or the majority of people would score between a 17 and 25. That is mine. Go put it away. That is mine. Go put it away.
So where was this at?
I don't know. On my desk. Go put it away. All right. Part B. What percent of data will be greater than a 29? Okay. Here's the deal. Josie a little bit ago asked me for what the symbols were. 29 is this guy right here. They want to know greater than 29. Okay? Do not. Do not.
Boy, spit water on me.
We don't care. Shh.
Spit water on my
He's
forehead.
about to get kicked out of this room.
Yeah, no. Kick him out.
Okay. Focus. We will be done shortly. Okay? All right. Greater than a 29. Here's what I want you to do. On this bell curve, we label 21 since he is average with a 0. Okay? 25 should be labeled with a +1. Why are you standing? Go sit down. You do not need a Kleenex. Go sit down. What is going on? Like, why are we all crazy today? 0 + 1, 29 is +2, 33 is +3. Okay? 17 would be -1. 13 is -2. 9 is -3. Yeah? That is how many standard deviations we've added and subtracted. So we've added 1, added 2, added 3, subtracted 1, subtracted 2, subtracted 3. All right. These numbers right here stand for something called a z-score. They stand for something called a z-score, okay? And a z-score is like a unit of conversion that we do when we're trying to compare two things that should not be compared. Okay? And an example of that would be like men and women's heights, right? Like it's not fair to compare a girl's height to a boy's height because boys are naturally supposed to be taller, right? Like it's not fair to say that this boy is taller than this girl because she's already at a disadvantage because she's not a boy, right? So we can compare two things. So what we do is we convert it to a z-score, okay? Another thing that might be compared, let's say you have an ACT score over here and you have an SAT score. ACT scores go from 0 to 36. SAT scores go from like 0 to 2,400 or something like that, right? So if somebody scored a 30 on an ACT, did they do a good job? Yeah, this is a good person, right? If they scored on an SAT, if they scored a 500, is that very good? No, but if I'm trying to compare those two things, it looks like the person that has an SAT score of 500 did better because that number's larger, right? So what we do is tomorrow we'll be doing a conversion that converts everything to a scale, and usually it'll be between -3 and 3 so that we can compare them to see which one is better. Does that make sense? We're converting to a z-score. All right, so let's go to your bell curve before we answer this question. Down here, Josie asked for what these symbols mean. Right here. Do you see where it says X bar right here in the middle?
Yeah.
Put a 0 right below that on your bell curve sheet, on your empirical rule sheet. Put a 0 right below that, okay? And then do you see where it says X bar plus S? That's like my +1. I'm adding it once, right? I'm adding 4 to the X bar number. I'm adding it once. Here I'm adding it twice. Here I'm adding it 3 times, right? Then on the other side, I have -1, -2, -3 over here, right? Do we see that? Okay, so let's go back up and let's answer that question. We have those labeled at the bottom there. So it's asking me on this question, what % of the data will be greater than 29?
Standard deviation, right?
S stands for standard deviation. What % will be greater than 29? Now, 29 is at the +2 spot. Do you see that? 29 is at +2. Do you see that from the chart? Okay. We're trying to know what % is higher than that +2 spot. +2 spot is this guy right here. Okay. So I'm looking at this point and beyond that way. Right? What % will be this mark on to the right? 2.5. I would add these two together, right? 2.5% would be in that range. Okay? And that's all that we do. The answer to that question is 2.5%. What % of the data will be greater? 2.5%. Okay? All right, let's go down to another question on the back side. This is the last example. Example 2. The heights of 1,800 adults. What is 1,800 representing? What variable do we use for 1,800? Do you remember? 1,800 is my N. That's the number of people we're surveying, right? Okay. With a mean of 70, what symbol do we use for 70? Or for mean? X bar. And a standard deviation of 2. That's S. S is 2. So this is the information that they just gave me. They have to give me that. Okay? Now, let's label our bell curve out. Okay? So this is like 0. That's in the middle. What number goes in the middle?
70.
70. Okay? Then I add it once. This number should be
72.
72, right? This number I add it twice. 74. This number I add it 3 times, and it's 76. Do we see that? We're adding the standard deviation once, twice, 3 times. Then I subtract. -1 would be 68. -2 would be 66. -3 would be 64. Okay, now we're going to answer the questions. It says about how many adults are between 66, circle where 66 is, and 74. 66 and 74. What station is 66 at?
-2.
He's at -2. 74 is at? +2. Okay, so go to your bell curve. Where is, so locate -2 and +2. -2 is here, +2 is here.
95.
What %? 95% is between those two. Not too bad, right? 95%. But here's the deal. It says about how many? How many students would that be? 95% times 1,800 or 0.95 times 1,800. Somebody do that for me, would you, please? 1710. Round to the nearest person or whatever. 1710. So that's how many people would have scored or would have added at a height that's between 66 and 74 inches, according to this. According to this. Okay? Next, part B. What is the probability that a random adult is more than 72? 72 is right here. 72 is at the +1, and I want to know that and beyond, right? So let's go to our bell curve.
That would be 16%.
And we're at +1 and beyond, right? So if I'm trying to find that, I add up all these all those percentages, and you said
16%.
16%, correct? Yes? Yes? Perfect. That's it. Oh, wait, but it asks for probability. What is the probability that a randomly selected person is between that? So you could say 16 out of 100. I would just leave it as 16%. That's a probability, right? You can have a probability as a percentage. That's fine. Okay? Questions about this? Not too bad. We're going to do the rest of it tomorrow, where we're converting to z-scores, doing all that stuff. Here's your homework. Ready? We'll label the top bell curve to... Oh, wait. Do this really quick. Before we go to the homework assignment, do this really quick. Go to the back of your empirical sheet, the one that's horizontal, and go to that chart. And they have, let's talk about these two bell curves. We're talking about heights, and they do a curve for men and a curve for women. Let's talk about the differences between these two, okay? The men's curve is to the right of the women's curve. Why?
Because they're taller.
Heights are larger. That's why it is shifted to the right a little ways,
Is it also
okay?
more
Now, here's the deal.
Why is it smaller than?
Here's the deal. Why is the woman's curve taller?
Because there's not so much like difference between the heights and
What's that called?
compared to men. There's not much
Variance. It doesn't vary. Or it's closer. The numbers here, or the women's heights are closer together. Okay? The heights for women are closer together. There's not as much standard deviation, right? There's not as much deviation. So, because the women's heights are closer together, you're going to have more women that are here on your towers because they only have like not very wide of a range of heights that they could be. So that shoves condensing it in shoves the tower taller. Does that make sense? Okay? So that's kind of why we have those differences in the men's heights and the women's heights for a bell curve, right? Okay, let's go to your homework assignment, which is this guy. We are on the cookie sheet. This is your homework. Your homework is the cookie sheet. It says 8-6. Okay? You are going to do all of the problems on the non-cookie side. So, don't cross this one out, though. Don't cross the cookie side out. What? Nice. Nice. You're only going to do the ones on the non-cookie side, but you're going to do all of them. Okay? All on this side. So, if we start using, let's label the bell curve. The average score on the last stats exam was an 89. What does that tell me? It's in the middle. 89 is the middle number. Okay? This is at my 0 station. Okay? Standard deviation is 3. So plus 1 would be 92. Plus 2 would be 95. Plus 3 would be 98. Minus 1. Minus 2. Minus 3. 86, 83, and 80. Okay, use that information and your bell curve sheet, the empirical rule sheet, to answer the questions. We are gonna do the backside, but not till tomorrow. Okay, so do all of them on this page. All of them on this page. Okay, use that bell curve and how it's labeled to answer the questions. Make sure that you have these changed to 95s at the bottom. The 13 and 14. Make sure you have them changed to 95. Okay. Questions? Before I stop the video? All right. Bye.